All right, ladies and gentlemen, we're going to go ahead and learn today how to write a polynomial equation from its roots. So essentially, we're going to work backwards. Okay, so you're going to be given the answers, and we got to turn it back into the original equation. But before we do, I want you to go ahead and try these two warm-up examples. These are examples from previous units and previous sections. And then on Google Classroom, in the comment section, go ahead and let me know if problem number 1, you got it, kind of got it, or you have no clue, and we'll call this other one problem number 2. All right? So go ahead and work on it, and then I will just give you the worked out answer. So if you want to pause the video before you do this. All right, so let's do some examples of where we're going to write the polynomial function given the roots. Okay? One thing I want to remind you of is multiplicity. As you recall, when I talked about multiplicity, it's when you have an answer or a root that repeats multiple times. So in this case, if I have a multiplicity for root 3, a multiplicity of 2, that means I have the answer 3 twice. And I'll show you how to deal with that when we're doing these type of problems. Okay? So we're going to write all these roots in factored form. And keep in mind that in step 2 here, that irrational numbers, numbers that cannot be simplified, like square root of 2, and complex roots, like I, will always have pairs. They're called conjugate pairs. Okay? So let me write that in. Okay? Which means there's always a plus or minus root. Okay, so we got to keep that in mind. All right, so let's go ahead and go through this. So example A, we're going to write all the roots in factored form. Okay, so if we look, we have 3i, 3, and negative 1. These are our roots. But since we have 3i, it's a complex root, we kind of have to write its conjugate, which means I have positive 3i, I now have to keep in account its opposite of positive, which is negative 3i. So I'm going to rewrite these roots, and it's going to look like this. So we're going to have 3i, negative 3i, positive 3, negative 1. Again, very important you understand that because I had positive 3i, I need to include negative 3i as my root. So even though I only have 3 roots for my original problem, in essence, I'm actually having 4 roots. Okay? So now we are going to really do step 1. We're going to write all the roots in factored form. So we are going to turn these back into factored form. And what that means is I'm going to take 3i and I'm going to turn it into a parentheses. Negative 3i turns into a parentheses. 3 turns into a parentheses. And negative 1 turn into parentheses. So how does this work? We turn them into factored forms. If we recall, all factored forms have an x. They're basically binomials with an x. So for 3i, when we turn the answer back into factored form, what do we do with the sign? We switch the sign. So this is really negative 3i. Okay, and now negative 3i turns into positive 3i in factored form. 3 turns into negative 3. And negative 1 turns into positive 1. Okay, so once we have that, we basically have already taken care of step 2 by doing the conjugate, doing the multiple signs. Now we simply just got to multiply everything. This is basically a multiplication problem. We're going to multiply everything together, but it's very important. You want to multiply the complex numbers, if you have any. You want to multiply them together, and then once we do that, then we kind of multiply these in. So let's go through this. So let's multiply these guys first. So this is going to be x times x, and that gives me x squared. And then x times positive 3i, that gives me positive 3xi. Okay, I like to put the variable before the imaginary part. Now we're going to go negative 3i times x. That's going to give me negative 3xi. And then negative 3i times positive 3i. That's going to give me negative 9i squared. Okay? So now before we even do this, I really want to simplify this out. And what you should notice is we can now combine like terms. X squared, there's nothing to combine yet. So we put x squared. Positive 3xi and negative 3xi, they turn into 0xi, so they eliminate. So these guys essentially cancel out. And then we are left with negative 9i squared. Okay, so I want to do a little side note here on what happens when you have I squared. Okay, so when you have I squared, what it really means, if you recall from IM2, I is really the square root of negative 1 squared. Okay, and if you remember, this is simple math here, square root and powers of 2, they actually cross each other out. So I squared is actually equivalent to negative 1. So if we do this math here, we really have negative 9 times negative 1, and that's going to give me x squared plus 9. So all this here, x minus 3i times x plus 3i, has turned into x squared plus 9, and we now still have to multiply x minus 3 and x plus 1. So I'm going to bring those down just to clean it up a little bit. And we're going to continue to multiply. All right? So I'm going to multiply, again, you could do it in any order, but I'm going to multiply these two together. So x times x, that's x squared. X times 1, that's positive 1x. Negative 3 times x, that's negative 3x. Negative 3 times 1 is negative 3. And we're left with x squared minus 2x minus 3. And now we have x squared plus 9 getting brought down. Okay, and then we're almost done. We now just have to multiply this guy times this guy, and it should give us our final polynomial equation. So we're going to go x squared times x squared, that's x4. X squared times negative 2x, that's negative 2x to the third. X squared times negative 3, that's negative 3x squared. And now we're going to go 9 times x squared, that's positive 9x squared, 9 times negative 2, that's negative 18x. And then 9 times negative 3, that gives me negative 27. And then last but not least, we are going to combine like terms. So x4, there's no other x4, gone. X thirds, we got negative 2x third, there's no other x third, gone. Negative 3x squared and positive 9x squared, that gives me positive 6x squared. And then negative 18x, and then negative 27. So this would be our polynomial. And that's essentially how you go from the roots and turn the roots back into what problem we should have originally had. Okay. Let's try one more example. So, example B. We have two roots, but remember, when you have an irrational, because square root of 5, we don't know what that answer is, so we have to put down its conjugate. So we have the negative guy, we got to put down his partner, the positive guy. So we have negative square root of 5. We need positive square root of 5 and negative 2. Once we do that, we want to write all the roots in factored form. So we're going to have 3 factors. This is now x plus square root of 5. This guy is x minus square root of 5. And this guy is x plus 2. And again, once we have our roots, we want to multiply everything together, but we want to multiply the irrational, in this case, the irrational roots together first. So we're going to go x times x squared, x times negative 5. That's going to give me negative square root of 5 x. Again, the x is outside the square root. Okay, and then we're going to go square root of 5 times x. That gives me positive square root of 5 x. And then square root of 5 times negative square root of 5. That gives me negative square root of 5 times positive square root of 5. Okay? Again, I wrote it like this so I can show you the math. So let's clean this up. We have x squared. These two guys, if you notice, negative square root of 5 and positive square root of 5x, they actually will eliminate, because negative square root of 5 and positive square root of 5, if we added those, it really give me 0 square root of 5. So these guys would eliminate. And then, last but not least, when we have square root of 5 times square root of 5, that is really square root of 25, bringing down the negative. And if you know how to do square roots, the square root of 25 is actually just 5. Okay? So all this here turned into 5, and it's negative 5. All right, so again, these two guys multiplied together turned into x squared minus 5. I'm going to bring down the x plus 2. And now we're going to multiply these two together and we'd be done. So x squared times x, that's x to the third. x squared times 2. That's positive 2x squared. Then we go negative 5 times x. That's negative 5x. Negative 5 times 2. That's negative 10. And if you look here, we want to combine like terms if possible. There is no like terms to combine, so this would be my final answer. Alright, we'll do example C, and then I will allow you to try example D on your own. So example C has this multiplicity. What this means is, again, if you recall, that means this root 2, it repeated twice. So I'm going to rewrite all my roots and not forget my conjugate here for the complex imaginary solution or root. So this really means I had 2 roots of 2. And then we have positive I. And we also, since we have positive I, we better have negative I. Okay, so in essence, we had a total of 4 roots here. So now we're going to turn each root into factored form. Okay, this first guy turns into x minus 2. Remember, we're switching signs again. This guy here is x minus 2. This guy here turns into x minus I. And this guy here turns into x plus I. If you recall the steps, once I have my factored forms, we took care of the conjugates. I want to multiply these two guys first because they are complex solutions. So multiply that out. X times x is x squared. X times I is positive x I. Negative I times x is negative x I. And then negative I times positive I is going to be negative I squared. So let me write that a little cleaner. Negative I times I. So let's clean this up. We get x squared, positive xi, negative xi. So it's basically positive 1xi and negative 1xi. They actually cancel. And then here, if you recall, this is really negative I squared. Okay, so remember, I squared is actually negative 1, but we bring down our negative we had before. So negative times negative 1, or negative 1 times negative 1 is positive 1. So all this turns into positive 1 here. Okay, and now we're going to multiply the x minus 2, x minus 2. Okay, so let's do this quickly. We have x times x, that's x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Combine like terms, we get x squared minus 4x plus 4. Bring in the x squared plus 1. And now we can multiply these two guys together. All right, so x squared times x squared, that's x to the fourth. X squared times 1, that's plus x squared. Negative 4x times x squared, that's negative 4x to the third. Negative 4x times 1, that's negative 4x. 4 times x squared, that's positive 4x squared. 4 times 1, positive 4. Combine like terms, we have x to the fourth. Then we have negative 4x to the third. Then we have positive 5x squared minus 4x plus 4. Again, try example D, pause the video, and you can try to work it out before you see the answer.